Elements, compounds, and mixtures. The essential question: what are the similarities and differences between elements, compounds, and mixtures? This lecture is going to begin our unit on chemistry. So we will start with the differences between these and talk about pure and mixed matter. And then we will talk about how atoms are structured. And then we will end by talking about the periodic table and chemical reactions. So matter can be pure or mixed. Most matter that we know about is mixed. So air, paper, tap water. Air is a mixture of different kinds of gases, water vapor and dust. There's oxygen, mostly nitrogen, other gases mixed in there. Even tap water that seems pure is not pure. It actually has minerals and chemicals in it to make it safe to drink, for example. Pure substances contain only one thing. So a pure gold bar that has only gold in it. Pure water that's been purified to get out the chemicals and the minerals, so it's only H2O molecules. So elements. Remember, we are comparing elements, compounds, and mixtures. So elements are pure substances. They contain only one type of atom. And a couple examples would be silver and oxygen. These are actually all the elements. This is the periodic table. There's a little over 100 of them. Some of them are made in a laboratory and they're not naturally occurring. Okay, but they do contain only one type of atom. So silver, if it's pure silver, that's just silver atoms. Okay, oxygen, the element oxygen is only oxygen atoms. Okay, next one is compounds. Compounds contain two or more substances that are chemically bonded together. So some examples would be H2O and NaCl. H2O is water. That's the Mickey Mouse molecule. And this is sodium chloride, that's an L. And this is table salt. So this is an example of chemically bonding two or more substances together. The black atoms right here are hydrogen, and if we bond two of those, hydrogen's a gas normally, with one atom of oxygen, which is the oxygen we breathe, we actually get a liquid water. Sodium chloride, if we bond a sodium atom with a chlorine atom, this is normally, sodium is a shiny metal, and chlorine is a toxic gas, but if we combine them together chemically, we get sodium chloride or table salt that we can eat. And the last one is mixtures. Most matter is a mixture. It's a combination of different substances that are not chemically combined. Some examples would be salad, an energy drink. Okay, those are not bonded together physically. We could pick those apart. So you can take the pieces out of the salad and separate them. An energy drink is sugar mixed with water and some flavoring and some coloring and some other things. But you aren't actually forming new substances when you mix these together. Just like air. Air is a mixture of different gases, but those gases stay separate. They aren't actually chemically bonding into new substances. And the last slide here is just a comparison of mixtures and compounds. Mixtures are substances that remain, where the substances remain the same. Kool-Aid is, like I said, sugar, water, coloring. We aren't actually making anything new, we're just mixing things together. They can be separated by physical means. You could filter stuff out, you could evaporate it. If I evaporated Kool-Aid, I would have some sugar and some coloring left in the bottom of the glass. And the ratios can vary. So you could have different amounts of sugar and water, for example, in your Kool-Aid. Compounds, we form new substances. So I mentioned the sodium, which is a metal combined with chlorine gas, actually makes table salt that we can eat. And you must break those chemical bonds to get those apart. So in order to separate sodium chloride, we would have to do a chemical reaction to pull those apart. And the ratio is fixed. So there is always 1 oxygen for every 2 hydrogens in an H2O molecule. That does not change.